Here's an example where we're given the coefficient, but we're asked to find a particular term. So in the expansion of 3x plus alpha to the 5, the coefficient of the x squared term is negative 90. So we're asked to determine the value of alpha. So when we're expanding this, again, as part of our solution, we're going to let a, i.e. the amount of movements to the left, be the first function, which is 3x. And our b function, which is movements to the right, be alpha. So note that we want an x squared term, which again means that we're looking for two particular movements to the left, which would imply that we're going to have three movements to the right. So we, as I said, we want to left, which implies that our coefficient is going to be the row number 5, choose the amount of rights which we need, which is 3. Right movements, excuse me. And we know that this is equal to negative 90. So we can write that 5 choose 3 times 3x, the whole thing squared, multiplied by alpha cubed is equal to negative 90. Now 5 choose 3 is 10. Multiplied by this, which is 9x squared. Multiplied by alpha cubed, and so that should have a 19x squared in it, because it's the full term when we expand it. So the x squareds are going to cancel. 10 by 9 is 90, so I'll have 90 times alpha cubed equals to negative 90. So alpha cubed is minus 1. Or in other words, one of our values of alpha is minus 1. We will later learn that there are technically two other possible answers to this, but for right now you can take alpha is negative 1 if we cube root both sides. That's how I managed to get that result.